When you look around in the .NET world, you'll find quite a lot of dependency injection frameworks. There is, for example, Unity, Spring.NET, Castle Windsor, Ninject, StructureMap, AutoFac, and many others. Personally, I really like AutoFac because it is very easy to set up. AutoFac allows you to structure registrations in modules, and it has also a great documentation on autofac.org. Beside WPF and .NET, it can be used in Universal Windows apps as well, as it is available as a portable class library. But AutoFac is just my personal preference. If you like to use another dependency injection framework, that's also fine. Okay, as AutoFac is quite easy to set up, we will use it now in the Friend Storage application. So let's switch back to Visual Studio. Here I'm back in the app.xaml.cs file where we create the new main window. Now let's introduce AutoFac to inject all the dependencies with the framework. So I just right-click on the references of the Friend Storage UI project and I say Manage NuGet Packages. I browse and I search for AutoFac. Here we go, and I install the latest stable version. Alright, now let's right-click on the project again and let's add a new folder that we call Startup. In that Startup folder, I create a new class that I call Bootstrapper. Okay, let's make it public and let's add a method that returns an iContainer. That iContainer comes from the AutoFac namespace, so we add a using for this. Let's call the method bootstrap and let's create that container inside of this method. To create the container, we need to create a new container builder. And that builder has a method called register type, and we can register a concrete type, like for example our navigation view model. And we can say register this type as an iNavigation view model. So wherever an iNavigation view model is required, the container will know that it has to use a navigation view model instance. Okay, I just copy this line 3 times and I do the same for our navigation data provider. Alright, I need a using directive and I say use this type wherever an iNavigation data provider is required. And the last one is our file data service. Okay, I use this type wherever an iData service is required. Now here it's interesting. We just register the type. But when you look into the app.xaml.cs file, you see that the navigation data provider requires a func. AutoFac is able to inject that func into the navigation data provider's constructor. We don't have to register a func in the container. It will know I have to pass in a func that can return an iData service. And it knows how to return an iData service because it knows that this interface is mapped to this concrete type. Alright, now what we also need to do, we also need to register the concrete types that we want to resolve from the container but that don't have an interface. When I go to the app.xaml.cs file, you see we need to register the main window and the main view model. So let's do this. Let's just copy this line and let's say register type main window. Okay, and we say here as self. And I do exactly the same for the main view model. Alright, now we have registered all the types and we need to build the container. We just do this by calling the build method on the container builder. And we return the iContainer from that bootstrap method. Now let's go to the AppStaml.cs file and let's create a bootstrapper here. Alright, and let's create the container by calling the bootstrapper's bootstrap method. Now we can get rid of this whole ugly block of code and we just say container resolve. The resolve method that I want to call is not here because it's an extension method. So I add a using directive here for autofag. Now when I type resolve again, you see there comes a bunch of methods. I use this generic resolve method and I say I want to have a main window. Okay, and the container will know how to inject all the required dependencies. So now let's, for example, add a breakpoint in the navigation view models constructor. Now I run this, and you see we have hit the breakpoint, and the data provider is the navigation data provider that we have mapped here in the bootstrapper to the iNavigation data provider interface. So let's continue, and you see the application starts up and the navigation is loaded. So now we are done with dependency injection. Whenever we add a new parameter to one of our view models, we don't have to adjust this code in the AppStaml.cs file anymore. So our app is now more maintainable. Alright, now let's wrap up what we have done in this module. In this module, you learned that writing testable view models means abstracting away dependencies. We defined interfaces and we have created constructor parameters in our view models so that we can inject these dependencies at runtime and in our unit tests. In our unit tests, we just inject a mock object that fakes, for example, the data access. Besides writing testable view models, you also learned about dependency injection frameworks that you can use to resolve all the dependencies for you. So you don't have to manually pass in all the dependencies to a view models constructor. Instead, you just need to register the dependencies in the container of the dependency injection framework. Alright, so now you know how to write testable view models. I hope you liked this module. I also liked it, but there was one thing I didn't like. Creating a class for each required mock object in the unit test is not really fun. And that's the reason why you learn now in the next module about a mocking framework, so that we don't have to create a class for the mock objects that we need in our unit tests. Welcome to the module Mocking Dependencies with Mock. My name is Thomas Claudius Huber, and in this module I will show you how you can use the mock library to mock the dependencies in your unit tests without implementing classes for these dependencies. Before we do this, let's take a quick look at the module outline. We will start this module by looking at the basics of the mock library. Then we will use that mock library in the unit tests that we have written already for the friend storage application. We will replace the classes like, for example, the navigation data provider mock class that we use in the navigation view model tests. Alright, so let's start now with the mock basics. What is mock? Mock is a mocking library that is available as a NuGet package. Mock is also open source and you can view the code on GitHub. The mock library is strong typed. You don't have to use magic strings to create your mocking objects. Instead, you can use, for example, lambda expressions. The mock library describes itself as simple and minimalistic. It was built to make it easy for developers to create mock objects. Now let's look at a piece of code. Let's assume you have this iDataProvider interface that has a loadString method that returns a string. In a unit test, you want to mock that interface. With the mock library, you can just create a mock of iDataProvider. The mock class comes from the mock library. On that mock object, you can set up the loadString method and a return value for it. As you can see, to do this, you use a lambda expression that you pass to the setup method. With the object property of the mock object, you get an iDataProvider instance. Behind the scenes, the mock library creates a dynamic proxy that implements the iDataProvider interface. So you have a real iDataProvider instance, and on that instance, you can call the loadString method. And the result will be, in this case, the string hello that we have defined above. Okay, so this is how you can set up a method. With the mock library, you can do much more. You can also set up properties, you can define callbacks for your methods, you can verify how many times your method has been called, and much more. Now we will continue in the friend storage application, and we will use the mock library. Then you will learn about additional features this library has.